We will start with Tadeusz Wibig from Łódź to give us an update on his activity within the CREDO-Maze task. So please, the screen is yours.
Representing a kind of branch of the CREDO project, the smallest one which can be imagined, because in the University of Lodz there are two people working in CREDO exactly. It's me and it's Michał, who is specialist in fact in electronic, in creating detectors, and I'm a specialist for years on cosmic ray physics, on many aspects of cosmic ray physicists. Here we realized the program which is called in Polish Kosmos widziany z Łodzi, the space seen from Łódź. We obtained some money for creating, say, set of arrays which will be distributed all around. In fact, we are going to place it in schools, in high schools in Łódź, in our university, and for few months we've got money for spread it all over the Poland and even more. And in each school which will be introduced to our program, we will set apparatus which consists of 4 cosmic ray detector, charge particle detector, and they will send the data, the events, the records of events to our Maze central server, and we will transfer it somehow to the central CREDO database. The scheme of this smallest array, cosmic ray array, is given here. It's not very complicated, because the idea of our project was to build cheapest array as possible, cheapest detectors and cheapest all around apparatus which can be done. And in fact, if we compare the cost of our detectors on all our electronics with another detectors and stations which will be presented here, I think yesterday or day before yesterday, on Monday, in fact, we are much cheaper than everybody. Okay, I don't want to spend much time on this graph, which is quite clear, I hope. The data will be collected from the detectors and transferred to the memory card, in fact, with the timing taken from GPS, and that's all. Nothing more is necessary. We built such detectors which are shown on this picture. There are 4 detectors. In fact, here in this picture, they are placed one above the other, making kind of a telescope which is looking for the single muon coming from the space. Here are detectors, and below is the central station. And in the figure we see the 5-hour counting rate for all different coincidence, 3-fold coincidence and 4-fold coincidence. And it looks like we expected nothing extraordinary. All is stable here. And here is the number of counts of different coincidence. And we can obtain some efficiency for each detector, and our fit shows that the efficiency of this single muon detector here is about 90% of each one of them. With this detector, we can obtain the cosmic ray shower data, and the data, raw data, looks like this. It's nothing special, and this is I think 2 months of something like that, from end of January to the April, how the coincidence work, how the rate is going on, how stable it is, and we see that it's all the time it's stable. There are some jumps, but we can explain with some changes of air pressure or something like that. This is test data. This is not our final analysis data. There's nothing changed. This raw data as they came to us. And one important things we done is test of the timing. We put two such an array, one close to another, just measuring the same extensive air showers, and we see the time difference between two such a small array, and this we can conclude that we have absolute time accuracy about 1 millisecond, something like that. This is enough for the looking for the CREDO cosmic ray ensembles. Our electronic looks like this. This is a central station, quite nice and quite empty. This is all some GPS receiver. This is antenna of the GPS. This is the memory card writer. Some processor of Arduino is below this card. And single detector, 1 of 4, is given here. This is a little bit complicated. There are some comparators. We can adjust the threshold for each detector, in fact, each channel in the detector. And we can also put the high voltage of the silicon photomultipliers in the detector here in the central unit. And this is all what we done. This is our production, our electronic we did. Now, not a prototype. This is ready for, say, mass production. And another thing we did is to produce the educational material. We published it in Fizyka w Szkole, the journal in Polish, and some articles are already printed there. The 5 is already done. The 6 will be published in the first number of 24th of this year. Okay, we prepare some also educational material for the teachers' school. And this is all I want to say, only this. If I have a few time, I can say something about the physics. We used our detectors in other not typical uses. We take them to the salt mine, just 300 meters below the ground, looking for the muons there. And we saw the result, which is close to the expectation, or even it's expected, the number of counts below. And another point, we put the same, our muon telescope, just to the journey through the Finland, just along for the different latitude, geographical latitude, to see how it behaves. The data we obtain from the fish, but they are not already. We are not working in this. We have no time to this. And okay, at present we've got the array placed in 3 schools in Łódź and very close to Łódź. Another is in the weeks will be put to some other school. We have the technology that children from the school coming to our faculty and building some detectors from themselves. It's interesting. They like it very much. And okay, that's all, I think. Thank you very much.
Thank you very much, Tadeusz. Questions? So we appreciate your activity, and you are one of the few successful grant recipients within the collaboration. So maybe it's not only one grant. We should mention the previous one. It's all so much encouraging, and I hope this would be kind of an example for the other groups. One question. So we call you task for the time being. But what if there are people interested in joining? Will you be willing to accept such volunteers or maybe professionals? So that is really because it's defined like a big job, and I hear some of sorrow in your voice when you say that you're only two of us working on that. It's such beautiful project, also with history, because it has a history. Maybe we don't tell it right now, but it's really something, and I think it deserves a larger group, maybe composed of not only from people from Łódź, but maybe other people, also international interest. So just a short question: will you accept if there are people interested in joining your task?
Okay, everyone can join us. It's a problem how to join, what everyone can do for this. Our main point at this time is to build the arrays. We have a technology. We have to know how to make it, and if there will be some other people who can build the detectors, will be very interesting to know what in what way it can help. Of course, we will be happy if there were much more of people, but this is a work which is local. I think here it's really hard to build detector if you are, for example, sitting in Krakow and trying to build a detector in Łódź or something like that. Some other activities, of course, are important. For example, the things which we need will be transfer the data to the CREDO database. It has to be done not with us, with other people, maybe people from Krakow, who knows how
we are discussing this separately. Of course, every detector system is welcome to upload the data. We have the open protocol, and if some expertise is missing, then we are looking for it. And I think that in this case, as I said in email, Sławek is the first contact person. And if this is not enough, we look further. So I take your answer as yes, the people might join. And there is a question how to organize work of a group, but this would be your duty as task leader. So so don't worry.
Yeah, I'm waiting for the proposition.
Exactly. So the answer is yes. I'm just translating. Thank you, Tadeusz. Take care, and we keep on going with the other presentation.